So I'd like to introduce Ethan Buchman of Eris Industries. And today, Ethan will be giving us an overview of both Eris and Ethereum. So, take it away, Ethan.
Take it away, cool. Do you know if we can get me on talking? All right, hi guys. So I work for Eris Industries. Eris is a company in the blockchain 2.0 space that has this heretic idea that we can have blockchains without currencies. You talk to a Bitcoin maximalist, they'll tell you that's blasphemy, and like rightly so. Maybe I felt like that a year ago. The thing is, I've been doing a lot of soul searching in this space, and we all have, and what we've discovered is essentially that blockchains as they stand today, with their built-in currencies, are almost too sovereign for their own good, in the sense that as great as they are, and as wonderful as these systems are, and all the game theory, and this stuff about incentive alignment and so on, the on and off ramps to the rest of society simply aren't there yet. And if they are there, they're happening through like large corporations, like whether it's Coinbase or BitPay or whoever, right? So Eris was founded by a couple lawyers with the idea that, okay, blockchains bring more to the scene than just politically decentralized currencies. They're ultimately a database technology that might be dramatically less efficient than sort of more classical database technologies, but they have different emphases. Oh, cool. And those emphases, in particular, on administrative domains within your database, over which different individuals are allowed to perform different actions. So they're essentially like databases with access control lists and all kinds of cryptography baked in. And that might not seem like much of a big deal, and maybe it isn't, but it's kind of a new primitive for thinking about how to put together a database for a company, not necessarily for like their large-scale web applications, but for more of their like back-end administrative stuff. So when I talk about like what is a blockchain and who might want to use one, and I think about Facebook, I often say Facebook the application probably has nothing to gain from a blockchain. It would just slow it down dramatically and no one would be happy. But Facebook the organization might have a lot to gain because of the way blockchains are organized and because of the way they can improve like auditability and transparency and the ability for employees and others to participate in sort of managing the database without having to have too much control over the whole thing, right? So on a blockchain like Ethereum or its derivatives, there are accounts, and every account can be controlled and administered by arbitrary scripts over sort of cryptographic logic, which allows you to be mathematically certain as you can be, that only certain individuals will be able to do certain things. And we think that's pretty powerful, and we're trying to see where we can go from there. And also, the underlying consensus mechanisms are pretty cool. They're kind of a step forward in general consensus theory, and we suspect that we can use them even without the built-in currencies and incentivize them with just sort of standard social economic incentives. So that's kind of, brief little background. If none of that made sense, doesn't matter. I wrote a little blog post on this just yesterday. So if you want to check that out, that's on the Eris blog sites. But today, basically, philosophy aside, we're just going to dive into some of the tech. And so again, basically the way we started, we were a bunch of guys building stuff on top of Ethereum. You're all familiar with Ethereum, right? Oh, cool. And we found, we had various frustrations with the stack. We wanted things to work a little faster, a little differently. And so in May, I believe, last May, well, almost a year ago, the three founders had pumped out a response to a bounty put up for $100,000 to replace the Bitcoin Foundation, to write software that would replace the Bitcoin Foundation. So they wrote what was at the time the biggest dApp on Ethereum, that was essentially a decentralized Reddit that merged Ethereum with BitTorrent to allow you to host like forums on the BitTorrent network and track them with contracts on Ethereum. So that got really popular. Some VC came around and was like, hey, we want you to start a company, we're going to give you a bunch of money, and then they hired me, and the rest is history. So anyways, what I'm going to show you today is take you through one of our staple tools, which is called EPM. It's the Eris Package Manager. It's evolved quite a bit since its original inception. It is undergoing a bit of flux right now, but I went through a little tutorial yesterday, and hopefully things are going to work smoothly for us. I was hoping to have done more this week, but I cut my hand open on Sunday, so You have to excuse me for that. Anyways, okay, so I guess first things first. So this is a little overview. I'll just run through that quickly, and then we can talk about actually installing and running the code. First thing you need to do when you're developing on Ethereum or Ethereum-like chains is compile the code for your smart contracts. So, sorry, my mouse is a little dry. Oh, there we go. Yeah. Okay. So, all right, is everyone here familiar with like the Bitcoin scripting language? Yeah, more or less. You've all written like basic Bitcoin scripts. No? Okay.
We've seen them thrown up on the screen in front of us.
Okay. Have you ever like walked through one? You all know what a stack is and what pushing data onto the stack means? And, okay, cool. What about the Ethereum virtual machine? No? Can anyone tell me maybe what the difference is between the Ethereum virtual machine and Bitcoin's?
Well, it's a state machine, so you can do loops.
You can do loops. That's the, as far as I'm concerned, that's like the least impressive part. So what else? Anyone?
Turing complete.
It's Turing complete. Usually people, that's the loop thing. Nah. What else we got? Okay, so the Bitcoin virtual machine, all it has is a stack. So you can push data onto the stack and pop it off and do very simple operations, check a signature, check a hash, whatever. With the Ethereum virtual machine, it's also got a stack, but it also gives you a memory array, so you can do more complicated operations, store things in memory, and it has a persistent state. So unlike a Bitcoin, unlike the way Bitcoin works, where it's almost like you have to write a new script every single time you want to do something, and you can't really reuse a script because you got to kind of spend all the outputs at once. With Ethereum, once you publish a script, it sits there forever. It sits on the chain forever as its own account. And that account is basically managed by the code in that script. And anytime someone sends a transaction to that account, it'll run the code. And the really nice thing about it is every account has its own storage. The storage is practically infinite. I mean, it's like 2 to the 256 spots. And each spot is 32 bytes. So you can store as much crap as you want in these accounts and have the contract logic manage that state and those state transitions. So as far as I'm concerned, the really interesting thing isn't that you can do loops, it's that you can store persistent state in a really nice way. So in Bitcoin, everyone has struggled or come up with various heuristics on how they're going to store data on the chain, whether they put it in OP return or wherever in the Coinbase. With Ethereum, they clean that up quite a bit, and it's really elegant, and you work with a proper, as if you had a dedicated storage for every account. So it makes it really clean for writing contracts and doing logic and stuff. So I'll take you through what some of that code looks like, because basically Eris uses the same virtual machine as Ethereum, maybe with a little bit of modifications. And so our first tool is our compilers tool, and this is there are multiple Ethereum languages right now. There's a LLL, which is the low-level language. There's Serpent, which is Vitalik's little baby, and then there's Solidity, which is the one that's seeing the most development and will be the primary language for developing on Ethereum. It's sort of JavaScript / C++ like. And so what the Eris compiler does is it runs on one of our servers. It has the compilers for all the different languages, and you ping it with your code, and it'll compile it for you and send you back the bytecode, and then you can deploy that on the Ethereum blockchain. We have found this to be super convenient, mostly because installing anything in C++ is often a nightmare, not least because it takes an hour to compile the first time, and you got to install all these dependencies. So having to avoid doing that has been super helpful. So we have this this little compile server up. We call it the LLC compiler, lovely little languages. That was actually Gavin Wood's term for his original Ethereum language. So we'll run you through how that works. It's actually really easy to add new languages to it. So if you happen to write an Ethereum language, maybe as a little project or some, to learn a little bit more about how the virtual machine works, we can easily add it into our compiler, and then anyone who knows the URL for where our compiler's at can suddenly have access to your language as well. So we'll run through how that works, and then we'll jump into actually using the state machine to running some of this bytecode on an Ethereum or Ethereum-like blockchain, and testing the contracts, making sure things work, and sort of debugging a little bit, seeing what that looks like, and then talking a little bit more about the EPM tool, what it can do for you, how it works, and then we'll jump into some more interesting stuff with Eris's fork of the Ethereum blockchain, More recently, we've been working on another kind of blockchain, which is called Tendermint, which is a proof-of-stake consensus algorithm. We're porting a bunch of our infrastructure to that, so we'll go through that a little bit. The nice thing about EPM is it's been designed to be chain agnostic, so it works on multiple different blockchains, all with the same sort of interface. So the same thing you do on Ethereum is going to work right away on Tendermint, is going to work right away on Eris's fork, which is called Thelonious, and you can just get started deploying blockchains. Deploying contracts and playing around with them. Technically, we say we support Bitcoin too, but we don't really out of the box. But it's not infeasible to do that. So maybe if someone's looking for a side project and wants to bring our tools up to speed with a Bitcoin chain, that'd be awesome. Okay. Anyways, all of our stack is written in Go. How many of you are familiar with Go? Cool. A few. Okay. So Go or Golang is Google's language. They pumped it out back in 2009. People have described it as what you would get if you took a bunch of C veterans that have been building in Python on Google infrastructure for the last decade and wanted a better language, and they produce Go. And a lot of people find it as like a nice balance between C and Python. It's everything statically compiled, it's very fast, it has amazing concurrency support. So right now the main Ethereum blockchain is written in Go, Tendermint's written in Go, most of our stack is written in Go, Docker, lots of nice tools today are being written in Go, and people are really loving it. So it's a lot of fun, it's really easy to get up to speed, and it's really clean and easy to read. So the first thing you have to do is install it. Does everyone have it installed, or where are we at on that front?
No.
No? Okay, you got it installed. Okay, so it's easy enough. Cool. Install Golang. Some of you, so if you're on a Mac, is everyone on a Mac? Wow, just about. If you're on a Mac, you should be able to brew install Go, assuming you have Homebrew. Does everyone who's on a Mac have Homebrew? Does anyone who's on a Mac not have Homebrew? No?
Not no.
Does anyone who's on a Mac not know if they have Homebrew?
There's a script for installing.
Okay, if you don't have Homebrew and you're on a Mac, that's the first thing you have to do, is get Homebrew. So Google Homebrew and download it and install that. It will make your experience on your Macintosh infinitely better.
In the Slack channel under the general.
It's basically a package manager. It's like apt-get for Ubuntu. Makes it really easy to install other people's code. Yep. Brew install Go, yeah, it should be. Do the non-Mac people have any issues? Are there any Windows people in the room? Are all these? Yeah, okay, crap. So I can't guarantee that everything's going to work on Windows. Some of it will. The compiler tool should. We've had some issues with some of the crypto before. So if you're on Windows, do you have access to a Linux box or a server somewhere that you can SSH into? Yes, no? Yeah, you shouldn't need this. You can just brew install or apt-get install Go.
Our Wi-Fi's not working.
Yeah. What's that?
Our Wi-Fi's
The Wi-Fi's down. Uh-oh. Mine's
So
not.
there's Tech code.
Check it out.
There's one Wi-Fi, and another Wi-Fi is CFLD Incubator Services,
Yeah, that's the one on.
and it has the same password, 1172 Castro, capital C, 1172.
Okay.
Okay. Everyone good? Presumably?
Thank you for your help.
We can keep going here? Okay. So, now the thing about Go, most programming languages like to give the programmers like the ultimate in flexibility on where their code goes and so on. Go took a different approach and they decided to be like pretty fascist about this. When I first discovered it, I hated it and I was like, okay, this is awful, these guys are idiots, but actually it turns out really great. So what they do is they force you to put all your code in one spot and to arrange it hierarchically according to where it came from and the author. So basically everything is under, you have to set the environment variable Go path. And if you don't do that, Go's just not going to work for you. So you can just create a new directory called Go or Go apps, wherever the hell you want, and then set your Go path to point to there. So if you don't have it set already, you can see just echo Go path. Mine's already set. If yours isn't, you can go export Go path equals, whatever, ... And to give you an idea of what it's going to look like, so within the Go path, you end up with these 3 main directories, bin, package, and source. All the Go binaries that you install are going to end up in bin, which is really nice. They're all in one spot. All the libraries are going to be in package, and all the source code is going to go in source. So what you're also probably going to want to do is put that bin directory on your path, so that everyone know what the path is? You know, there's some sort of newbie Linux people here. So if you don't know what the path is the place where your command line looks for executables. So when I type ls and it knows what that is, it's because ls is located in one of the places that it's looking. So the places where it's looking is your path. So this is all the places where mine is looking, separated by colons, and you'll notice that my Go apps bin is on there. If yours isn't, all you have to do is export path equals $path : go path /bin.
Can you increase the font?
Yeah, totally. How's that?
Yeah, it's great.
More? How big does it get? Is that too big?
Too big.
Okay. Cool. So that the last step isn't really necessary, but it's just a major convenience so that you'll always be able to find things. Now, really though, this whole exporting stuff, when you export variables just from the command line like this, they don't persist. So when you open up a new terminal, those variables are going to be gone. So what you probably want to do is stick them in your bash profile. So if you don't have a .bash profile in your home directory, make one, and then at the bottom of it, you can put your stuff. You shouldn't have to write your whole path like that. I don't know why mine is, but anyways. And then anytime you open a terminal, the Go path will already be set. Everyone okay with that? And then I guess really it should look like so just those 2 lines. Okay, so just going to show you what it does in here. If you go to your Go path /source, it'll have any websites that you might download code from. Go is basically designed as a tool for open source code. So it expects you to be pulling your code from GitHub or Bitbucket or gopackage.in or etc. and actually stores it on your disk under that directory. So if I look under GitHub, I'll now see all the different people I have from GitHub, including Eris Limited, and then there's the Eris Limited repositories and so on. So it's really nice and clean like that, and you always know where to find your stuff. Now, whenever I start a new Python package, I never know where the hell to put it. So I've been spoiled by Go. So this is my actual one. The nice thing is you can, if you ever want to try excuse me, a fresh install, you can always just export a new Go path and then go get things to that. I haven't mentioned GoGet yet, but everyone got their Go path set? Anyone not? Okay, so why don't I export a new one export go path equals users EU go whatever. Okay, so now Go makes it really easy to get someone's source code. You just go get it. Go get. I should blow this out a little. So we're going to start with the Eris compiler tool. So it's go get github.com Eris limited /LLC compiler, and then we'll go LLC server, sorry, /cmd/LLC. Of course, I don't have internet. It happens.
Can you repeat how to create a path if you don't have one created already?
Sorry?
Can you repeat how to create a path if you don't have one already?
How to create a path?
Yeah,
Yeah, sure. Go path or path?
go path.
Go path, really easy. If you want to do it just one off, you just type export go path in capital letters equals, whatever. I'm users bat Buddha something.
Thank you.
If you want it permanent, and I recommend it permanently, you should do this. Open your your home directory .bash profile. This is the file that gets loaded every time you open your terminal. So if you have like any other settings that you need to take effect every time you open that, I've got some crap in there. And basically what you want are these two lines. Ignore all this other stuff. Yeah?
Try.
Okay, so I'm gonna stick, everyone good? Anyone not?
Can you pull up the other screen where, like, what were you go getting from?
Yep, so it was go get github.com Eris-LTD LLC server CMD LLC server. And so what that'll do is it'll now create the LLC server in my bin directory, and it'll pull all the source code down. So there's Eris Limited, LLC server, there's all the code. Maybe we open the
Repository
repo.
not found.
What's that?
I'm getting repository not found.
Which one from?
Repository not found. You are missing a. No, we're just missing a thing here. LLC server.
Yep. Yeah. So if we look at the repository itself, GitHub Eris. So you could just go get this guy. The thing is, the actual executable is inside CMD LLC server, so that's why we had that. But then, so if you've done all that and you're all set up, you should be able to type LLC server and it'll do that. Better yet, LLC server help. Hey, look, it's me. And then if you're really daring, you can actually go into the folder, into the tests, and try and compile something. Wow.
What is .sol? What is that?
That's Solidity. So I'll jump into that in a second. Yeah.
Should really do though.
Where's everyone at? Has anyone successfully compiled that contract?
What? Oh, we're supposed to do that.
If you want.
What's the command line?
Presumably, alright, so far is everyone at least at this stage where they can type LLC server help and see a useful output, presumably useful output? Yeah? Anyone not? You're not? Where are you at?
Well, when I started doing basically the martini listening came up, but never did anything.
Oh, that's fine, just quit, you add -- help next time. Yay. Anyone else? Cool. Okay. So this repository comes with a test folder with a whole bunch of Ethereum smart contracts. So we can CD into that and take a look at some of them. So it's going to be in GoPath, Source, GitHub, Eris, LLC server, tests. And once you're there, we see a whole bunch of contracts.
Can you do that by just getting into the folder? Or no, you have to.
At least maybe Chris.
What do you mean?
Headlines, users,
Thanks.
This new on 9,099.
Yeah, that's if you start the server, then you're running your own local compile server. What's that? Yeah, you can't see it in the browser, but if you go to /compile, localhost 99, go back, /compile. That's fine, it's expecting a payload underneath, so, yeah, that's fine. But, yeah, that's okay.
Yeah.
Cool. Okay, cool. So, now that you have the tool, you can run your own server locally if you want. The problem is that's not really going to help you because you don't have any of the actual underlying compilers installed to turn like Solidity code or Serpent code into Ethereum bytecode. We have all that done on our server already, which is at ps.erisindustries.com, and that default is already baked in there. So now when you type LLC server compile, it's gonna ping out to that server, ask it to compile whatever you're sending it, and then send you back the result. And so that's what we're gonna. So we're really only using this as a client-side tool just to compile contracts and make sure they're working. If you want to run your own server with your own compilers, it's best to do that using Docker. Are all you familiar with Docker? Yes, no? So Docker is a Linux container, and Linux containers are basically like super lightweight virtual machines in the sense that they give you, so when you're running a container on a Linux machine, you're sharing the same underlying kernel, So you're sharing like the same resources and like management that happens under the hood, but you have like an isolated process tree and an isolated file system and sort of like isolated network access. So so on any Linux machine, you can run a container image, which is like a standardized, fixed image of what an operating system looks like after some things have been done to it. So it makes it really easy to get up to speed with some software in a particular state without having to fiddle with all kinds of installs and so on. So all you have to do is install Docker, and then you download someone's Docker image, and then you have some app running, whatever it may be. It may have like 100 steps. You don't have to worry about any of that because the image has already been taken and already exists. So we have Docker images for all our stuff. I can show you what it takes to get set up a little bit later with like the compile server and your own Docker image. It's literally like a 2-minute endeavor, including setting up a server. So it's pretty amazing how quickly Docker can get your application up to speed. So and actually most of our stack is starting to move in a Docker direction. The EPM tool hasn't quite gotten there yet, but it will be under the next couple months. But anyways, that's all on the side. So if everyone can go and, yeah.
You said Eris forked Ethereum.
Yep.
Is this bytecode compatible with standard Ethereum?
Yeah, so what we're going to be doing right now is Ethereum stuff.
Can you repeat the question?
The question was Eris forked Ethereum, and is this bytecode going to be compatible with Ethereum? So the idea is that this compile server is like a very general purpose tool. And the actual languages we're using are the Ethereum languages. So that bytecode is directly compatible with Ethereum. The EPM tool allows you to use multiple different blockchains. So you can use the Ethereum blockchain and this LLC compiler tool, and everything will work just fine. And if you want to use the Eris blockchain, then that'll work fine too. But just to keep things familiar, we'll just work with the Ethereum stuff today, so that everything is like good to go. And when Ethereum launches, whenever that happens, you can jump on board. Okay, so now in this test folder, I have a whole bunch of contracts in here. As I mentioned earlier, there are like 3 main Ethereum languages: LLL, Serpent, and Solidity, symbolized by the 3 extensions LLL, SE, and SOL. So if we look at what one of these looks like, say the name reg, that's an LLL contract. It looks kind of gross. You probably don't want to have to deal with that, bless you. If you look at Serpent, it's a lot cleaner. It looks like very much like Python. You define some functions, you do some basic stuff. It's got white space and so on. And Solidity is kind of the latest and greatest. It's also really nice. It's more like C++-esque, where you define contracts as like classes and then fill in methods. Yeah. Anyone have experience writing like Solidity or Serpent? Not at all. So this is all Chinese, so to speak. It's all Ethereum languages, so to speak. Great, okay. So I'll run through what this means really quickly. So again, with an Ethereum contract, when you wanna set up a new contract, say you want to start, I don't know, a subcurrency on Ethereum, call it Ethan coin, right? So we could have a contract that looks like this. We'll use the Serpent one as an example. And so all we have to do are define a few functions that we want to be able to be called in this contract. So I'll write the code, I'll compile it, I'll send a transaction on the Ethereum blockchain that has the code for this contract as the data, and it'll get mined into a block, and now there's going to be a new contract on the Ethereum blockchain with the code I want in it. And anytime someone sends a message to that contract or a transaction to it, just like sending a transaction to another account, but now you're sending it to a contract account, it'll execute the code inside, right? So what code is going to execute? Well, I need to offer some options. So we'll define a few functions, and Ethereum has gone a long way to building a sort of higher level interface to the virtual machine so that it looks like you're actually calling functions as if it were like a typical class structure with methods on it, and then you call those functions. So in this case, we have our subcurrency contract. It has 3 methods. The initialization method, which runs only once when I deploy the contract. And all it's going to do is it's going to say, okay, in the storage for this contract, under the key given by the address of the sender, which is my address, store, what is that, 1 million. So when I create this contract, all that's going to do is initialize my balance in this contract with 1 million Ethan coin. Is that sensible? right? So this is like high-level serpent notation for accessing the underlying Ethereum storage, right? So Ethereum has opcodes for storing stuff in storage and for loading it in storage and then manipulating it on the stack and so on. And these are just like the high-level primitives for accessing, you know, the address of the sender and for accessing the storage in that contract. So when I first deploy the contract, this is what will run. And then later on, I can either query for a balance or send money, right? So the balance query is easy enough. I'll pass it an address. It'll look up that address in storage and return that value. So if I query with my address, it should return 1 million. If I query with someone else's address, it should return 0, right? And then if I call the send function, I'm supposed to pass it 2 arguments. The person I'm sending money to and how much I'm sending. And what it's going to do is check my balance. So it'll look up how much I have in storage. It'll just create a little variable to see who the sender is. And it'll check if, oh, it looks like, yeah, that is easy. If the value I have in my account is greater than the amount I'm trying to send, then it'll send it. And all sending it is manipulating storage, right? Look how simple that is. It's just going to set in my account, it's going to subtract the value, and in the person I'm sending it to, is just going to add the value. Bam, you have a currency, right? So in like, you know, 10 lines of code, you can start your own currency on Ethereum. You can set your initial distribution to be whatever you want, right? And go from there. So, okay, so if we try and compile this thing, LLC server compile subcurrency, you will see too much output. Sorry about that. We need to clean that up a bit. There's the command. There's a bunch of stuff. Don't worry about any of it. All that really matters is we're compiling remotely, so it's pinging this server, and it has returned the bytecode. So this is what the bytecode looks like in hex. It's just a whole bunch of manipulation to make all this work. And then here's I'll get into what this is in a second. Has anyone tried that, or are we just going to watch me and then we can try and dive into it later? What do you say? Yeah? Yeah, so what's happening is the LLC server, so Eris is running a server in, you know, on DigitalOcean or something like this, and we have a Docker image up there that has all the Ethereum language compilers running. So, and we're running a little the server software, like literally just this. Oops. That's running on that remote machine, so that when I type LLC compile, it pings out to that machine, sends it the code I'm trying to compile. It'll compile it according to the language extension. So in this case, it was .se, which means it's Serpent. So it'll look up the Serpent compiler locally. It'll compile it, and then it'll send me back the result. And that way, I don't have to have the actual compiler installed on my machine. All I need is this little Go tool, which, trust me, is a lot easier to compile and install than Solidity. Serpent's actually really easy to install locally, but Solidity's not. Does that make sense?
How long does it take to compile? Like, you're going on HTTP
Yeah.
to compile in that
Yeah.
server and coming back?
So you just saw it live. I mean, it took like a second. Here, I'll remove. So everything gets cached. So if we do it again, compiling remotely, there it is. So it took like a second or two. All right, and so this is the hash of the code. We just use this for reference, and this tells me whether or not it's already cached locally. In this case, it's not. If I do it again, now it's cached locally. You see it was way faster to compile it again because I already have the code, right? But if I change something in the code, I don't know, maybe let's give myself more money. Then it'll ping it out to the server again. Right now, it doesn't have a cache because it's different, and the hash is different, etc. Make sense? Cool. Okay, so the thing about Ethereum prior, about maybe up till like, you know, November or something, was actually interacting with contracts was kind of difficult. There was no like standardized way to outline functions that the contract could execute, nor how to really call them. So everyone would have sort of like arbitrary ways of doing it. You'd send like the first byte of data you'd send to the contract would be like a number that would tell you which number function you want to execute, or maybe it would be a little word. So they've cleaned that up a bunch. It has obscured the underlying virtual machine execution. So if you're trying to debug by eye, and you'll see what that looks like in a few minutes when we get to it, it gets a little messier, but it's a lot cleaner to interact with because it feels much more like an object-oriented programming language. And the way they've done this standard is through what they call the ABI, or the Application Binary Interface. All the ABI is a standard for how to call the functions that have been defined in a Solidity or Serpent contract. Okay, so when we looked at that subcurrency contract and it had these three functions, the init function is just like a default function that all contracts should have. That is the code that will run only once when you deploy the contract. You can never call the init function again, right? You would have to deploy a new contract. The other two functions are the actual functions that this contract exposes to the world, so that anyone can send messages to the contract and have either of those two functions execute. Now, so when we actually compile it, not only does it return the bytecode, it also returns the ABI, which is the specification for those two functions. It's just like a standardized JSON form that various other software can interpret for how to format your data when you want to now talk to this contract, right? So we haven't deployed this thing on an actual blockchain yet, so we can't actually talk to it. We'll get to that shortly. But when we do, this specification will be important under the hood, because we're going to do something like, we're going to go transact with the subcurrency contract, and then we're going to tell it balance query, and then our address, 0x, whatever, right? And so because of the ABI specifying that balance query is a function that's available that takes a single argument, it'll know how to interpret my command, okay? But we'll see what that actually looks like in a minute. So before we get to that, I'm just going to mention a couple things. So once you run any of the Eris tools, they will create a directory in your home directory called dserver.dserver. Dserver used to be, or dserver has been, our like main tool that sort of sits above EPM and these compilers to allow you to use basically JavaScript to talk to various distributed backends, whether it's Ethereum or Bitcoin or IPFS or BitTorrent and so on. But in that folder is like all the organization for all the stuff. So all the blockchains go in the blockchains directory. Scratch is where everything is cached. So if we look in there, we've got all kinds of cached contracts, so that I don't have to wait if I want to compile things again. And you can set a new dserver folder just by exporting the dserver environment variable. So I've changed mine to be new dserver. So if I look in there, in the Scratch folder, I see the things I was just compiling. And you see that the ABI gets cached in there too, just so it doesn't have to ask for it again. So when you're compiling stuff, or if ever something seems a little off, you can just delete that Scratch LLC folder and try it again. And that'll make it actually ping the server again. Okay, so the other nice thing that's in there is the actual configuration. So if you go in languages/config, here we have a big JSON file illustrating the different languages that are available. Really, the only important thing if you're using the remote server is the URL. So you can change the URL to be whatever you want. Maybe our server's down or something. You need to set up your own, and that's really all that matters. But then when you're writing, if you happen to write your own compiler one day, all you have to do is add your language to this configuration file, and then the LLC server will be able to serve it, right? And really all it takes is specifying the command from the command line to get the bytecode out. Solidity prints a bunch of extra stuff, so that's why there's all this like grepping and awking and so on. But none of that is too important, unless you're writing your own compiler. Okay, so that's the basics of the LLC compiler. We use it for everything all the time. Apparently other people have been using it too, and it comes in handy, and it avoids having to install big C++ binaries, so that's super helpful. Any questions on that front before we sort of go further? No?
What does ABI stand for again?
Application Binary Interface. it defines a standard for how to send data to an Ethereum contract to execute the function you want to execute, right? So we'll actually go through the Ethereum execution code and you'll see what it looks like. Okay, everyone good? Did anyone actually compile? Yeah, great. Okay, now, I heard at one point we were going to be taking a break. Is that what you're coming up here to tell me?
Yeah, taking a break, and
Okay.
I've got 2 visitors today.